PX35 plus longer. Start recording the waveform. Start the engine. After 3 to 5 seconds, slowly depress the throttle to raise engine speed. Then release the throttle to let the engine return to idle. Rapidly increase the engine speed. Turn off the engine electronics, but keep the throttle open until the engine stops completely. Stop recording the waveform. Select Analysis, Run Script to run the automatic analysis of the collected data. The PX script provides a report with the results of the measurements and calculations. There are several tabs presented using text, tables, graphs, and animations. The script will automatically analyze various measurements and render a diagnostic report, which can be found in the summary section of the Results of Analysis tab. In the case of this vehicle, the results are faults are not detected. This report can be printed out and given to the customer. Consider this report from the PX script for an Audi A6 with a 2.4-liter V6 engine. The amount of gas loss is 66%. That is far beyond the typical range of 15 to 20%. The script summary indicates the cylinder is losing compression. The script is capable of identifying other issues. As an example, insufficient exhaust valve clearance and a sticking variable valve timing adjuster. The PX script displays the actual valve timing by automatic analysis of the gas amount changes in the cylinder. An interactive animation demonstrates the real process of gas exchange in the cylinder. Variables such as initial installation of the camshaft, stretch and slack of timing chain and belt, valve clearance, shape and wear of the camshaft lobes, and the variable valve timing system are automatically taken into account during the automatic analysis. During day-to-day usage of the script, it would not be necessary to manually examine the waveform as the script automatically calculates valve opening and closing events and their impact on the operation of the engine. For this engine, the PX script reported insufficient filling of the cylinder and found that the cause of this condition was valve timing anomaly detected. The measured closing angle of the intake valve has gone beyond the typical range of 570 to 600 degrees. The results of the filling of the cylinder are available in both table and graphical form. In the table, a list of engine speeds and measured values show the cylinder filling is below the typical range. At the same time, the filling diagram's red graph line, corresponding to snap throttle, is positioned below the expected area. Consider the test results for a Ford Focus 2 equipped with a turbocharger. The results clearly show that the turbocharger operates above 3,000 RPM and increases engine torque by approximately 20% in the 4,000 to 6,000 RPM range. The script also tests another important engine system, the exhaust. The script can estimate exhaust system restrictions. This result is from a cylinder of a Chevrolet Spark. The exhaust system restriction not only created a power loss during the exhaust stroke, but also adversely affected cylinder fill. The cylinder's contents could not be emptied, so no fresh mixture could be introduced. The loss of fill density causes a reduction of power. As a result, at engine speeds above 3,000 RPM, any power developed by the cylinder is spent on clearing the cylinder's contents. Because of this, the engine speed cannot be increased any further. If the synchronization pickup is used when data is collected for the script, then the ignition timing can also be checked. When checked, the ignition timing advance is measured not only at idle speed, but also during different load ranges. This example shows incorrect base ignition timing. This result was obtained from a 2007 Mitsubishi Lancer with a 1.6-liter engine. Base ignition timing is not adjustable. Diagnosis and teardown revealed that the reluctor for the crankshaft position sensor was incorrectly installed.